Well, the first thing that I think about this problem is that it really doesn't have anything to do with torque. I think this might just be a force problem. Let's look at this situation right here. The man is pulling downward, whoops, wrong color. The man is pulling downward with a force that's called F, and then the tension of the string is pulling upward, and that's why the rope right here and his hand are not moving, right? So that means that the tension minus the force that the man pulls with is equal to 0. So that means that the tension in the rope is equal to the force that the man pulls with, right? So we're going to use this. Tension's equal to F. So if we look at what's happening right here and draw a free body diagram there, we have mass times gravity of the backpack, and then we have these two rope forces coming out, right? It's the same rope, so those are both the tension in the rope, which is equal to F. So let's just call that F. So we've got these two F forces pulling out in these two diagonal directions. So if we want to do the forces from the free body diagram, we put our axes in here. We've got the x-axis and the y-axis. And we see that mg is right on the y-axis, but we have an angle here for the force vector. It's the same on both sides because the problem is symmetric. So we need this angle here, theta. And what they gave us to tell us about theta was they told us that the rope had sagged a certain amount. They said that it's a certain distance, d, I'm going to call it d. It's a certain distance d between the trees, but the rope had sagged in the middle a certain distance that I'll call s, the sag distance. And now the rope looks like this. And this is essentially where we get our two f's from this part, this angle here, where the rope has sagged down. So the angle that we're looking for is this angle down here, which by alternate interior angles is the same as this angle up here. So that's also our theta. And with SOHCAHTOA, because this angle right here is a right angle, SOHCAHTOA tells us that S over D is opposite over adjacent. That's equal to tangent of theta. And since we know S and D, we can calculate theta. So that's good. So we take, now that we know that we can calculate theta, we can write our x and y equations. Our x equation is going to be f cosine theta minus f cosine theta, right? One to the right, one to the left, equals 0. Well, we already knew that. That's 0 equals 0. That's boring. Maybe the y equation will be something interesting. The y equation says that f sine theta, from this one going up, plus the other one, f sine theta, minus mg equals 0. This tells us that 2f sine theta equals mg, so f equals mg over 2 sine theta. So since we've calculated theta from this, we can calculate the force from here. And you just have to do that twice for the two different problems.